class. This is physics with Eshemohai, and I will be teaching you something on that motion, that is retardation, and also after that I'll teach you on free flow. So in my last class I talked about the meaning of motion and some equations of uniformly accelerated motion. I talked about that. And in motion, I talked about motion is the change in position of a body or an object in respect to time. Then I wrote some equations for that uniformly accelerated motions, where I wrote some equations like I wrote v equals to u plus at. If you can remember, I also wrote something like v square equals to u square plus plus 2as. I also write some other things like s equals to ut plus 8t squared. Then the last one I wrote again was x equals to bracket v plus u over 2 bracket equals to t. These are the equations for uniformly accelerated motion. But this is not what I want to take today. I want to talk on retardation and free flow. When I'm done with those ones, then in our next class, I told you that this topic is going to be divided into 3 videos. That is the first set in motion, this one that I'm about to do now. Then the last one that's going to end with calculations. So we will now calculate as many as we can. Then I can even give you some assignments so that you can, where in your free time you can calculate motion, so you can be a pro in calculation of motion. Get ready, we're about to start on the topic in motion. Thank you very much. Let me clean this, then we start properly. Just give me a second. Alright, let me arrange my board. So many of you will know that it's under motion, because some people may not know it's under motion. Let me write the motion here. It's still a topic under motion. I did not write it on top before, so let me just write it there so we can begin. Now, retardation. Let's start with retardation. There's something you need to know about retardation. Retardation is basically negative acceleration. Are you getting me now? So when they talk about retardation, we are talking about basic negative acceleration. Are you getting me now? So negative acceleration is, when a person is driving a car. So if a person is driving a car, the process where you match your brake is the retardation. So that is what it is, the process of the car coming to rest, that is retardation. So I repeat myself, the process of the car coming to rest is retardation. So let me write it on the board for those who want to copy. Now, retardation is negative acceleration. Now, pin this down. This is what it is. It's basically a negative acceleration. Now, the process when you get retardation, first, if you match your car or you put your car on brake, is retardation. If somebody is running to a speed, maybe when you start running, the speed at which you want to start running can increase. So the more you increase your speed, that is your acceleration. Then when you are reducing it to stop, that is retardation. Are you getting me now? So where, that is as an example, e.g. examples of retardation, when a car starts coming to rest, that is retardation. That is when the acceleration starts reducing. Now let me write it mathematically. Retardation is basically negative acceleration. So retardation is equal, let's not write it, is equals to negative acceleration bracket minus a. Are you getting me now? So negative acceleration is retardation. So that's what you should know on retardation now is retardation is negative acceleration. When a car starts coming to rest, it's basically retardation. Now mathematically, retardation is equals to minus acceleration. And minus acceleration, whenever you see minus a, they are telling you there is minus acceleration. Now let's talk about free flow. Alright, let me talk about free flow. Now, free flow vertical motion of a body under the influence of gravity. So the vertical motion of a body under the influence of gravity is free flow. I repeat, the vertical motion of a body under the influence of gravity is basically free flow. Like, so let me pin it down so anybody that wants to write can write. Now, free flow is the vertical motion of a body under, don't forget it's under the influence of gravity. So this is free flow. That's good. Now you understand free flow. Now let me make an example. Like now, if I one thing about free flow is that if I throw my marker up and I catch it, this is the influence. This is basically free flow because I threw it vertically and it is under the influence of gravity. And whenever something is under the influence of gravity, gravity pulls something down. Are you getting me? So when we enter Newton's law of gravitational field, maybe that may be our maybe after I do projectile, then I'll do Newton's law of gravitational field. So people should watch out for all my videos. These videos are going to help you very well. Now, let me when I do Newton's law of gravitational field, you will see what I'm really talking about here. Are you getting me? Now, that is free flow. Are you getting me? Like now, I threw my marker up. It's under the influence of gravity. That is free flow. So whenever something is, whenever you hear vertical motion under the influence of gravity, just know that it's free flow. All right. Now, let me write. We are still talking on that motion. Let me now tell you. Let me now write for. Let me write formulas for free flow. Let me write the formulas for free flow. Now the formulas for free flow are. Now let me write the formulas for free flow. Wait. Alright. The formulas for free flow are mathematical formulas. See, we have V equals to U plus for free flow. Now, free flow is mathematical. I did not write this before. Pin this down before you write these formulas for free flow. First, write this down. Whenever you have free flow, your S in motion, the S that we always know as distance, your S that you always know as displacement in motion, turns to H. It turns to what? H. So S is equals to H. So write this down before you write mathematical formulas for free flow. I get it. Write this down. So all S always turns to H. Now let's write it down. Now this U plus U is this V equals to U plus AT1. These are the one for free flow. 2. We have V square equals to U square plus 2A. It is no more 2AS. It's now 2AH. Another one is Another one is instead of S, you put what? H. H equals to V plus U over 2 bracket T. Then the fourth one is H equals to UT plus AT square. Are you getting me now? Now this is for what? Free flow. This is for free flow. So this is what you should know under free flow. Are you getting me? These are what you should know under free flow. So in our next class, get on physics, get ready for calculation. We'll just keep doing calculations after calculations after calculation. Then you will understand the motion very well. Thank you guys very much. My name is Eshemoka, as you know, and God bless you. Watch out for my next video. But don't forget to like, subscribe to my YouTube channel, follow me on Facebook, and you will learn physics and other science, the other three science courses that I always do, that are maths and chemistry. You will learn them very well and you will understand them very well. This is understanding science with Eshemoka. Thank you very much.